Hello and welcome back to Compiler Programming. Today I want to work a bit more on the parsing of expressions. In general, I'm pretty happy how the things are set up right now, where we have this shunting yard style algorithm here that is pretty straightforward and it allows us to parse expressions. So it consists of two parts. The one is here that deals with the token and then sort of puts them into two stacks. One is the token stack, the other one is operator stack. But one thing that I don't like with all of this is the fact that we cannot really make good use of the knowledge of where the result of the expression needs to go. That means that we create way more temporaries than necessary, and also the lifetime of those temporaries is a bit harder to figure out once we gonna get to optimizations. Yeah, and that means that there is way more things in the stack there should be, and so on and so forth. I can actually show that we again have quite a messy disassembly after changing the parser, something that I never addressed. So at some point, the assembly actually looked pretty neat, but now we again have lots and lots of stacks, stores, and loads, and it's just not great. We can actually look at I don't know which function would be a good one. Well, let's look at Fibonacci maybe. So if I make a step here, let's make sure that the project is compiled and try to run this. So if I go to this assembly and then I will step inside. So what you see here, for example, is a really inefficient move. So we take RBX, we move RCX to RBX, then we add to it, which I think is, sorry, something is my voice, probably need more tea. Yeah, I think this is this add, right? So we add to N1, but then, yeah, so this is the -1 here that we put at 70H, and then we load N into RBX, which is currently in RCX, and then we add, and then we store again all of it to stack, and so on and so forth. And you can see there is a bunch of these loads and stores from stack and to stack and so on. Like there's just a lot of that. And this is not great. And the reason that happens is because, again, when we do the dispatch, for example, let's look at this arithmetic, right? There is the fix me here. So it's exactly what I'm trying to address right now. And the problem is, again, we don't know where the result of this expression is going to go. So we have to put a temporary stack value into here. And the reason that happens is because with this algorithm, you are doing, I think is post order traversal of the tree. So it's like breadth first, post order traversal. Yeah, there is a pretty good illustration, I guess. Maybe I like that one. Yeah, we are doing basically something like that. And since we are doing it that way, when we are evaluating, for example, 4 here, which would be one of the operators, or maybe this one is a good image. Let me take a look. Yeah, so this seems like a pretty decent image. We are doing it essentially this way. It's a post order depth first traversal. and we want uh, this one, depth first pre-order traversal. This is what we want. And in order to switch from one to the other, we need to actually change how the evaluation is handled. And right now there is no extra temporary structure, so we don't really have any kind of abstract syntax tree here. We have a token tree, but this is very bare bones. It only has braces that are grouped into nodes. And here we're just doing it right away. If we want to do this different style traversal, maybe it's possible to do it without constructing an extra tree. I'm not sure. But before I spend too much time thinking about it and figure out like maybe some funky algorithm and doing some research, let's just do the basic option that we have, and that is actually construct this tree. Since this is a throwaway tree that is gonna only live for the duration of the parsing expression, I'm not actually worried about any performance or anything like that. So let's just figure out how this is going to work. And the tree is also going to be a bit special in terms of like it's not gonna, the types of nodes will be very implicit. We'll just have a pointer to the function that will handle a particular operator instead of sort of this will act as a type of the node. I guess before we can do any of that, that means that we need to change this setup slightly so that we actually do have these handlers set up. So maybe what we will need to do is to transition to this setup where the handlers are defined dynamically for each of the operators. So let's do some refactoring, I guess. Okay. How does the handler look like? I think in value. Let's see. Program. Yeah, program init. So this is our only custom handler, and we need to turn, I guess, all of them into this. Would that be actually necessary, or can we make it somewhat better? Actually, we probably don't need to do that right now. We can make dispatch operator into something nicer. Yeah, okay, so I know what the first step is. The first step would be here to invert this setup and split this into two functions, maybe. This is quite a chunky boy, but we can do something about that. Maybe later on. Okay, token, dispatch operator, and token. This is no longer dispatch. This is process. I know I'm not very creative with names today, but that's okay. Do we already have token handle operator? Yeah, we do. That's actually the main thing. Okay. Eval operator. This was can be called. And this token eval operator will accept everything like that. No. What it will accept is now slightly different. It will actually get the arguments I mean, it does look like the handler then. Hmm. Well, let's just start typing something in. So this is what I have in mind. It will accept an argview and it will accept handler payload. Not sure that we would need that for now, but that's fine. And it accepts value star result value. Do we need the operator entry? Maybe yes. So let's actually roll this back slightly and add this result like this and see what that might look like if we do it that way. Okay, that means that reversing of the argument will be handled by somebody else. And this is also going to be handled by somebody else. Okay, that looks great. Token stack, argument count. We don't need to do that. That also should be handled above. That means that the argument count also goes away here. Okay. And here we now need to replace all of these with token view get args view 0 and args view 1. Okay. And that makes sense. And I guess the same thing will happen in a lot of other places. So let's just copy this stuff so we can have it better. Yeah, that's argsu0. That's going to be argsu1. Okay. Actually, now it's other way around because I expect this to be in correct order. Yeah. So this actually needs to, this now will be in correct order. When there is only one thing that is much easier. argsu 0. Okay, what happens here? We are redeclaring a result value. Yes, that is no longer going to be the case. Result value is going to be passed to us from the outside. We also don't need to do any result token stuff. So let's get rid of that result token right away so that we know how this is going to happen. And that actually means that here this handler no longer returns it will not operate on a token level but rather on the value level. Okay, context argsu payload, yes. And here we will need to pass in result values somewhere. This will cause an error, but this will be a reminder for me to actually go and fix that up. No more result token. Result value, result value. And this is something that I will add a marker here. This is something I need to look into as well, how that would look like. Handle cast, result token. Yeah, this also needs to be changed. This needs to be changed, and this needs to be changed. Okay. Token view get args view 0. We don't need to do this. Compile time eval also needs to accept the targets then. And that's another thing to fix. Okay, what do we have here? Token view get args view 0 and args view 1. So right now I'm just doing this mechanical translation where I'm removing the token wrapper for all the results of this evaluation. So previously we would literally do the stack where we would evaluate an operator and put it back on the stack, evaluate next operator, put it back on the stack. And in order for the operators and all other tokens to be the same, we had to wrap it here, wrap an actual value in the token, but that should not be required anymore, hopefully. Yeah, result value. This is another place, so we instructed Hill. We also need to get it the target that we can use. Okay, same things goes here. Token view get args u 0, args u 1. Okay, I don't need the result value anymore. That sounds correct. And more of these things. Okay. Now, again, what we came here for, ability to get rid of these stack reservations that are very explicit and just do it this way. Okay, now we have 3 arguments and they are in opposite order. Yeah, so that's something that we need to fix. This is token view get args view 0. Args view 1 and args view 2. Okay. Result token, function value. So we have again the problem with the fact that we are just creating this value here. Well, this will be an error anyway, but let's add another marker as well. Okay. And there is nothing here. Well, we need to move out it as well. Okay. Result token. no longer exists. Token stack no longer exists. So what are we left with at the moment? Let's go through it step by step. We have the handler here, and that's something that we need to fix up. Handle operator proc, yes. So now you're gonna be void, and you will have value star result value. Okay, so this fixes this, but it obviously will break other stuff. Yes, a handle user defined operator is now gonna be slightly different. Value star result value. And that means that we don't need to do this anymore. Okay. This also shouldn't be returning a token anymore, but that's a separate thing that we need to take care of. I guess actually, yeah, it now looks like this, right? We put result value here, yeah. So that looks fine to me. Who else do we have? So this is array access, and I guess there is somewhere assignment here. I want to steal that to put in other places. That's an error. So basically that's what I want. I think at least. And we would say now that where are you? You're not result. You're array element value. This might actually cause issues that I'm doing right now, because previously we would get sort of a reference to an array value, and now we will assign to it. Yikes. So fix me. This might actually cause problems in assigning to an array elements. This is something to think about, but we can deal with that. And for the source range, I can take brackets. Yeah. Okay. That seems fine, at least for now. Here we have a cast. Okay, we have a target, we have args token, good. And cast now needs to receive a result value. So let's do that. Value star result value. You no longer need this. Okay. You no longer need this. And you're no longer. I guess I need to. So value is what we get here. We have an integer, we try to cast it. There's a bunch of logic for handling immediates, the signed and unsigned ones. How would that look like now? We don't want to assign it here. Instead, we say after cast value. Okay. And here we would do that assign context context. This shouldn't be value pointers. This makes sense. This should be token view, args view, and then this should be, yeah, this is a pretty old function that they have here, so it's good that we looked into it. It uses old API, and we can make it better. Okay, so it, now I get it why it used that. Why it was the way it was, but that's something we can okay, let's leave it as it was. It's fine. Context, source range, result value, after cast value. Well, that seems to compile. I have to wrap this, even though it's technically not necessary. Okay. What else? Or who's next? Next is operand variant of. It has exactly the same issue. We need to pass in this stuff. That's because it was modeled after a cast, so naturally it looks exactly the same. Value star result value. Can no longer return anything. And what if we try to remove these and remove these? So this actually creates a value. So what we need to do is to say value star operand value, and we are gonna move it Well, let's keep an old setup here. It's fine. Can assign context, source range. Then we need to have a target, which is result value, and we have a source, which is brand value. Okay. Missing a star. That looks better. Handle cast. Don't need this anymore. Okay, what else is happening here? Handle function call. You are in the same boat as everybody else. In particular, you need to have, you were returning a token and you were receiving a result. That is very, very interesting. So I think that this is like this actually. Now I'm interested in what it looks like. Okay. Return result. Result is token value make. Yeah, we don't want that. We don't want no result. So how would it look like without the result? Well, I guess in here, what is the return value? Here return value is result value. So I guess call function overload also needs to accept a result now. Do I want to do it right away? Well, since we are on the big refactoring spree, let's just go for it. Probably would be better to do it incrementally, but you know, oh well. Sometimes you just have to dive right in and hope that everything is fine. So after a call, where are we dealing with result of this? So that's returns result, but where is result defined? Return size. Okay, result is descriptor returns. Gotcha. So that means result, reserve stack, move value, source range result, descriptor return. What is happening here? Okay. Maybe I will not touch this for now. I will add fix me, accept result value. Calling function is always a bit finicky, so let's just not do that. Instead, we will say it like this: value star return value, and then well, we can do it like this: assign context source range result value return value, and here we will remove the return value. We done this one, result value, result value. I forgot to undo a bit more stuff. Okay, that should do it, but we'll see. Okay, compile time eval. Well, that has sort of the same issue, that right now it doesn't accept. Here we need to say value star result value and not make it return one. Yeah, so this is no longer result value. This is like a temp result. And instead of returning it, we would say assign context. Do we have a source range here? I don't know. Result value temp result. I'm also not sure that this will work very well here, but we will see. Count time result. So now you are an error. It's actually in the constant operator, where we don't particularly care about this. Value any of context locator. Okay. So this is should no longer be a problem. This is also goes away like this and goes away like this, and I guess here we need to return, and here we now can pass result value like everybody else. We are no longer creating this. Okay, that's I guess good. We cannot have this stuff, and we cannot actually assign to it. So struct get field needs to get a result value like all the other places. Where is your implementation? Are you here? Or you're here? That's unexpected. Probably should move you. Okay. This is also a very old function that we haven't touched in a while, which on one hand is very good. That means that things work. On the other hand, that is not so great. So here, yeah, I think I need to move this thing because it will not work otherwise. I need to here return assign. Oh, we don't even pass the context here. Yeah, population context, context allocator. Create the value. Context. We don't have source range here either, which is kind of yikes. Well, I guess let's pass in one. And we need the target, which is result value, and we need the source, which is called result here. I don't want to be called result, I will be called field value. Okay. So this is eval operator. I think it's like this source range. And so, okay. Much better. Who else do we have? It seems fine. Yeah. We have functions to deal with. That is the most awkward part of all of this because functions, they actually, like when you try to move a function from a literal to a value, it changes type to a pointer the same way that it happens in C. So this might be slightly awkward. For now, I'll just do this. And then we'll see, I guess, what is going to happen with all of this. Like so. Okay, so now I think our eval function is finally ready. And now, what would be a good next step so we don't have to spend another hour trying to get to a state where things compile? I guess the next thing would be to do the following refactoring, We will always figure out what the argument count, and I will need to make sure that here it's actually always present. It is not, but we can quickly add that. So argument count is 2. For majority of them it will be 2, but for some it will be, for example, here it's actually 3. Here it's 1. The same is here. 1 for unary minus. 1 for taking an address off. Multiplication, division, remainder, plus they all take 2 arguments. This also all takes 2 arguments. This takes 2 arguments. And we are out of operators. Okay. So negation handler is actually wrong. And that is because this now also needs to say value star result value. Now you complain that you are different from your prototype. Okay. Result. This whole thing is very broken, to be honest. But what can you do? Assign context token source range negated value and I was just thinking that I probably could use fix me, use a result value here, I guess. But I need to look at this function more anyway, so let's not do everything at once. Result value, negated value. Okay. Now we have a problem in constant operator. Value star negation result is value any contents allocator. It's actually the other way around. It's like this. And we say token value make context token. I think it wants more arguments. You also want the source range. That is not a problem. We will just say to you, oh, this one is actually missing a source range. Source range is okay. That is good. Did it fix the issue here? Yes, it did fix the issue here, and everything here is fine. And we can get back to I can remove these two. Okay, let's get back to here, to the wrapper that was doing this stuff. So for now, we will not be changing much. In fact, we will actually be making things worse, and that will also stress other systems of a compiler, because what I'm going to be doing right now is... Now, here's the question. Should I create a stack value here or any value? I guess I need to create a stack value, and then we'll see how it goes from there. Or maybe not. Let's be adventurous and see how terribly things will die now. So we create a value that can be anything, and well, we need to fix this. If we don't have enough tokens in the token stack, then it is a no-go. We do the reversing of the arguments, like so. We create a result value. Okay. And what else? Well, and now I guess we are ready to call token eval operator. Well, we can do argview here. Eval operator, that will get the context, that will get what it gets: context, argview operator, entry, and result value. Okay. Where was I? I was here. Context, args, operator, entry, and result value. So this replaces all of that jazz, which now deals with other things. And obviously in here, we need to say token star result token is token value make context result u, and we need the source. There is the same problem as we have in other places. So, but this will go away, so I don't actually want to do anything here. Result value. Okay. And then convert from array const token pointer. Good. Result token redefinition. Fine. Fine. And fine. Okay. So, looks like we only need to fix this compile time eval. And we are building. Now, this is gonna go very, very wrong, but we'll get to see how spectacularly it explodes right now. Yeah. Okay. So, what is the issue here? We managed to call function with the wrong tokens. Did I forget to... Yeah, I think... Which test is this? Brand variant of... Why are we... Well, I guess because I screwed up and ended up in the wrong dispatch. So there is this eval operator and the function call. I mean, target and args token should be correct, I think. Operand variant of... Target is first, args token is second. That seems reasonable to me. Okay. Let's see that again. And actually go a bit up. So what is our target here? Oh, apparently we no longer have access to locals here. That is kind of annoying. Args you... So what is args-u? Args-u has two tokens. The first one is group and it's 5. I mean, that seems pretty broken. Can I look at why? Yeah, so they seem to be other way around. So I didn't need to flip them here? I guess not. Yeah, right, because we are pushing it on the stack. And well, let's just try to not flip them. I guess that will tell us if that is correct or not. And to not flip them, we actually need to do slightly different thing here. Capacity. And so we need to know the length of the current token stack. Okay, let's do this push and initialized. And then I want to go again, and I would say that star dynamic array get of args I is dynamic array pop token stack. This is actually not I, this is argument count minus I minus 1. Something like that. Let's try again, I guess. So, is it any better with our tokens? Well, now we have ID in the right place and we have, so we actually don't need to reverse arguments. That means that this could be much better. Before we proceed, then let me change the comment and say can probably just use a slice of the stack without copying. Okay, that is good news, I guess. Well, let's continue and see what else breaks. Okay, yeah, that is not good. Operand value of, great. Context, or not context, allocator, allocate context, allocator value. Great. Does that help? Well, that definitely seems to do something. So now we should have something in the result value, and it is an immediate. So let's, I guess, let it run and get the next crash. We don't get a crash, but we do get a bunch of fail tests. So let's look at them. What is actually failing? Wow, isn't that nice? Not much actually fails. And I think both this stuff and this actually has to do with the fixed size array handling. So yeah, what I was worried about. Maybe? Actually, I'm not sure. Let's look at this incompatible type, and that might give us better indication as to where we are coming from here. Okay. This is forced value, parse expression. This happens at the very end. This is always a pain in the butt to debug. So which test are you? Yeah, you're this test. So I guess token. So that's probably this one. That would be my guess. At the end of the expression, this is what fails. Maybe. Our statement. Yeah. So you are unhappy inside of force value that you try to assign and the target and source are incompatible. And the source is any. Okay. And the target is also any, I assume. Actually, no. The target is correct. Target is our return value. But the source is any. And that means we probably need to take another look at this function and exactly what happens here. We can actually look at it in the debugger and see what's going on. Yeah, so that's the right place. Great. We get the target token, we get brackets. Let's verify that they're correct. They seem to be. And right now we are on the left hand side of all of this. And let's see what will happen. Token parse expression. What is our index value? Index value is an immediate. It's an 8-bit immediate. Everything seems pretty fine to me. We create the item descriptor, item byte size, k, operand byte size, fine. Index value is immediate. So we go into here and we basically just, this index is 0, yeah. Okay, that all makes sense. I guess. Maybe not. Okay, I know what the issue is, at least one of the issues, is that here we are doing this in the wrong place. Okay, that would kind of explain this stuff as well, maybe. Let's see if that helps at all. Okay, that actually does help, but there is still definitely a bug around here, and it definitely has something to do with so what we're gonna do now is try to change this setup. Before we return, we will put it on a stack the same way it was before. This will go away. That's what we are trying to get rid of, but in order for this to go away, we will need something else to happen. And for now, this video does get a bit too long, so I just want to get it to the working state and call it a day for now. Value star stack result is reserve stack. I never remember what you want. Want context allocator, builder, and descriptor. Okay. So that's fine. And result value descriptor. I guess in here we need to verify that we didn't have any errors. Context result, return stack result, yes. And now we're going to assign context, source range, stack result, and result value. So all that I'm doing is I'm saying any kind of call to an operator will now put a temporary value on the stack. This might actually break even worse than the previous thing, but it also shows where the problems are. So that is good. And at least these needs to work because that should always be correct. Like we should always be able to put the value on a stack, I guess. Maybe. I don't know. This definitely break things. And maybe I shouldn't do that actually either. Yeah. That's an interesting question. Should I dive deeper into this stuff or should I actually steam ahead and try to make further changes? I guess let's actually steam ahead. And see how it goes. So something is broken with FizzBuzz, and I guess it is connected to the temporaries because right now we are using a temporary here. Let's take a quick look at the assembly, but FizzBuzz is a pretty complicated example, so it might take a while to debug what is going on there. But we can take a look. There's still seems to be a bunch of very unnecessary moves. Did I rebuild afterwards? I just want to make sure that I'm on the latest version of this. Okay, so in order to debug something like this, we also will need to look at the source code. So let's open up FizzBuzz and start looking at stuff. So right now, what we're looking here is this function. We are saving RBX, whatever, loading -11, calling this function. That's all completely irrelevant. We are storing result in racks. Now the next question is, what is RSP plus 90? Okay, so yeah, that sort of makes sense. This is a broken function call. But we already have a comment to remove these two moves, so that's fine. So let's start. The way that I debug usually assembly is I try to figure out what are the right names for the variables on the stack that correspond to this stuff. I might even try to do it automatically soon-ish, but for now, that is not what I want. Okay. We have plus 90, and that is int 64. $92. Yeah, so this is actually a handle. It's kind of a handy thing that you can put a comment in here and it still works. So yeah, we have a handle. The next question is what is at 88? And actually also handle is at 88. So that's fine. 87 is I. And this is actually very interesting. And this is int 8. So right now I is 0. We will what are we trying to do here? No, yeah, we initialize it to 1. So now I is 1. We compare it with 100. If it's greater, we jump to the end of the loop. This is not greater, so we continue. We are moving. So 70. So this stuff 78H is 64-bit and it has print number which says true. Okay. Now we do the division by 3. Okay, we divided by 77H. Yeah, so we moved in I into AL and then we moved 3 into this memory and then we did ID by this stuff. Okay, that so far makes total sense. We are doing this stuff. This does not seem right. We should never do that. So what's happening here is we are moving a lower byte of the stack pointer into R11B. And that makes no sense. Okay. Now the next question is, how the hell did it happen? So this is part of the comparison. And okay, so there are several problems here. Problem number 1, that okay, so here's what we're going to do. We are going to actually take this stuff and re-enable it back in here. So wait a second. We should not create this value. We should do result value here right away. And then there's not going to be any assignment. Is this going to help? I don't know. Let's try and see. That did exactly nothing. That's kind of disappointing. So what shall we do? What shall we do? Let's take this stuff and return the stack here. Value star stack result is reserve stack context allocator builder LHS value descriptor. Okay, we are changing it back to this thing, and we are doing this setup. This should help us keep correctness till the rest of the refactoring is over. But let's see if that actually helps. And it does. Okay. Yeah, so the issue here is that somewhere we are ending up with a temporary value that is not correctly tracked yet. But again, this should go away once the rest of the refactoring is over. Okay, so in terms of functionality, nothing much has actually changed, but we cleaned up a bunch of old functions. We prepared the setup for further optimization, and that is already good progress. So I guess that would be all for today. Thank you very much for watching, and hopefully see you next time.